Hello, guys, and welcome to another episode of Coding with Pizza Technologies. It's been a while. I'm back, and I'm back with an episode where we're going to be doing machine learning. Now, we will start with an overview of how machine learning models work. Um, let's do some notes. Okay. So, uh, machine learning. We will start with how models work, and now we will get into the introduction of this. Now, like I said, we'll start with how machine learning models work and how they're used. This may feel basic if you've done statistical modeling or machine learning before, but don't worry, we'll progress to building powerful models soon. Now, in this course, we'll have you build models as you go through as you go not as you go through scenarios. There will be many scenarios. For example, let me give you an example of a scenario here. I'll just write it down for you or paste it from some of the notes that I have done. Sorry. Wow, that is long. Okay, so your cousin has made millions of dollars speculating on real estate. He's offered to become business partners with you because of your interest in data science. He'll supply the money and you will supply the models and predict how much various houses are worth. You ask your cousin how his predicted real estate values in the past, and he tells you, or he says, it's just intuition or a hunch. But more questioning reveals that he's identified price patterns from houses that he has seen in the past. And as he uses those patterns to make predictions for new houses he is considering. Now, machine learning works the same way. Okay, so still part of the notes. Wow, that is a long place. Machine learning works the same way. We'll start with a model called a decision tree, but they are fancier models. Now, that give accurate predictions. But decision trees are easy to understand. They are basic building blocks for some of the best models in data science. Okay, now I'll screenshot for you something. Let's actually do the screen snipe and then I will show you in a short while. Now, as you see here, sample decision tree. Uh, does the house have more than 2 bedrooms? If no, it has a predicted price, and if yes, it has a predicted price. That is a sample decision tree. So it has two prices. You can either have it at a higher price or at a lower price. In the event that it has more than 2 bedrooms, you will have it at a higher price. In the event that it has a maximum of 2 bedrooms or lower, you will find it at a lower price, as you can see here. I hope that makes sense. Now, it divides houses into only two categories, like I said, more or less. It is basically a probability. It's a 50-50 situation where you'd either have one or a zero, or okay, the most or the minimum one or a zero, or yin and yang, basically. I think you understand what I mean. Now we use data science, or we use the data to decide how. Let me write it down. Sorry. We use data to decide how to break the houses into two groups. Then again, to determine the predetermined or the predicted. Or instead of houses, take examples of betting sites. Betting sites use machine learning to predict the football scores or analysis of any game that has been played or will be played in the coming future. That is the best thought of machine learning that I could think of at the time. Now, you can now improve the decision tree. Improving the decision tree. Let me okay. So, which of the following two decision tree is more likely the result from fitting the real estate training data? I will do a screenshot for you, and then you will understand what I am asking. Now I'll bring it forth so that you can see. Now here we have our first decision tree, where if the house has more than 2 bedrooms or not, where if the house has less than 2 bedrooms, it has a less price, and if it has more, 3 and above, it has a more higher price. Well, and the second decision tree comes where if the house has less than 2 bedrooms, it has a higher price. When the house has more than 2 bedrooms, it has a lower price, as you can see here. Now, the decision tree on the left, I think I should just take a screenshot again because I have just closed that without saving it. We'll sort it out together. Now, write down in red today. The decision tree on the left, I have done a circle in red. That is the decision tree on the left. Now the decision tree one, or the decision tree on the left, probably makes more sense because it captures the reality that houses with more bedrooms tend to sell at a higher price than the houses with the fewer bedrooms. The biggest shortcoming of this model is that it doesn't capture most factors affecting home price like number of bathrooms, lot size, location, etc. Now, you can capture more factors using a tree that has more splits. I will show you in a short while. Uh, uh, Let us do another screenshot. Then I should show you that screenshot. Aha. Now, now you can capture more factors using a tree that has more splits like this one. These are called deeper trees. A decision tree that also considers the total size of each house's lot might look like this. Now, does it have more than 2 bedrooms? Yes or no? Uh, does it have a lot size larger than 8,500 square feet? Yes or no? Then it gives you a predicted price. And with this, if it has a yes, then does it have a lot size larger than 11,500 square feet? If it's a yes, then it gives you a higher price, and if it's a no, it gives you a lower price. Now, you predict the price of any house by tracing through the decision tree, always. Picking the path corresponding to that house and the house's characteristics. The predicted price for the house at the bottom of the tree, at the point where the bottom we make prediction, is called a leaf. Okay. The splits and values. Splits and values at the leaves will be determined by the data, and so it is logic enough for you to check out the data that you will be working with. Now, on the next lesson, I think I will be teaching on the software that we will be using for just writing or doing the models. I could even talk about it right now so that by the time we get to the next lesson, you guys will be ready. Okay, so I think I should just save this first. Okay, now press it. If you go online, I should show you from the online perspective. Anaconda. Anaconda Navigator. Now, Anaconda Navigator, if you open this, this is a desktop graphical user interface that allows you to launch applications easily. Okay. Now, Anaconda Navigator is what we use for Python, artificial intelligence, and machine learning, writing the codes on that. Now, you will need to have Conda, which is Conda C install. You can run the package with this. I will show you how. Now you go to download Anaconda. I will put the link in the description below. You let it load. You go for the 64-bit graphical installer. Depending on your machine, you can have the Windows, the Mac, and the Linux user. Currently, I'm using the Windows 10, so you download for your Windows here. I already have mine, as you can see. I won't download it, but I already have it. Okay. Now, it will ask you to create an account. Please create an account here because you can use this as your cloud account for Anaconda, the free hands on Jupyter notebook, which we will also be using. I will also show you how to use other notebooks like the Spider notebook, the R environment, you name it. Now, there are those packages that come pre-installed. As you can see, there is Jupyter, there is SciPy, there is Spider, there is NumPy, there is Dask, there is Broke, there is Skitit, Learn, there is Number, TensorFlow, Holo, Views, PyTorch, Conda, Matplotlib, and Pandas. These are all used to build machine learning models. Okay. Now, after you have installed it, uh, you can just go to your start and then go to the Anaconda Navigator here. You wait for it to start. It will definitely start with the prompt from the command prompt. That starts the terminal for it. In fact, it starts 3 times or 4 times sometimes, or even 5. You never know how many times it will start. Depends on your machine. Mine, it has clearly started 5 times. And you wait for it to load, and it will add the featured and load the user. We'll still wait. Finally, it is open. Now with this, you have the command prompt, the data law, which is an online data analysis tool with smart coding assistance by JetBrains. You will have the IBM Watson Studio Cloud. You will have the Jupyter Lab. You will have Jupyter Notebook, the PowerShell prompt, PyCharm Professional. You will have the Qt console, the Spider, VS Code. You can install it as a third party, or you can come and install it with the Anaconda Navigator. It is very, very handy. You will have the Gluviz, which will give you a multi-dimensional data visualization across files. You will have the Orange 3, which is for the data mining framework, and you will have the R Studio. Now, you can click. R Studio happens to be the largest, so it will take the most time to install. These other two will install very easily. Once you have installed everything, you have to restart your computer for everything to be implemented. Okay. Now we will start with Jupyter Lab. I will launch mine because I know it will load. It will open via your browser, as you can see. I have to reload mine. It will open as a local host, and then it will load very, very nicely. Now, it will load everything on your desktop. You will just open, most likely add a new folder. A new folder, personally, I will call mine machine learning models, where if you open, you can open something else like a Python 3 IPY kernel, which will give you an untitled IPYNB, which is a Python notebook, and you can write code on that. This is what we'll be using. This is the environment we will be using to write or to create the models in the machine learning systems that we will be doing. Till we meet again, have a splendid night to all. Thank you.